So in this video, we're going to apply the properties that we learned in the last couple of videos. And I have an example here that for a limit as x approaches 2 for x cubed minus 2x plus 7. We want to find the limit for that. So what is that value, y? Let's see here. So if we have our basic rectangular plane, and we want to know as x approaches 2 from the left and the right, what will the value be? What will the value be for y? So we want to know not exactly 2, but as it approaches 2, what value are we getting to? So let's take a look at x cubed minus 2x plus 7. And let's notice some things that we can do. First, we have subtraction and addition. And we learned that one of our properties says that anytime that you have terms, and this is a term, here is a term, and here is a term. So when your terms are either added or subtracted, so this is a polynomial, then we can separate those. That's one of the rules or properties that we can use to solve this. And when we do that, we want to make sure that we're still defining that we're looking for a limit. Until we find it, we're going to rewrite this as the limit as x approaches 2, and we'll write our first term in there for x to the third, and that's going to be minus, and then again we will write as the limit as x approaches 2 for 2x plus the limit x approaching 2 for 7. Now, in this case, we still can't really solve this. We have a couple of things that are in our way. Our first limit for x cubed, we can use another property which allows us to bring that exponent outside and then solve for just the limit x. So when we do that, we're going to end up with the limit as x approaches 2 for x. I'll put that 3 on the outside. Next, we have multiplication. We have 2 times x. So we can separate this and we can say that as the limit for x as it approaches 2 for 2 multiplied by the limit as x approaches 2 for x. Then we're going to add plus, and this one is fine. We've reduced it down to just a constant. So as x approaches 2, the limit is x approaches 2 for 7. And now we can probably see this a little bit easier. In the very first video for properties, I was explaining how this works as a limit for x as it approaches a is always going to be a. And when we looked at the graph and what that meant is that from either left or right, as we approach some value, in this case 2, for x, we are going to end up with an output of 2 as well. So if x is approaching 2 from the left or from the right, x must be 2. So we have 2. But we need to remember to bring that exponent back down. So we're going to have 2 to the third minus, And in looking at this, this is a constant. Anytime that we have a constant, whatever the limit is approaching, it's going to be that constant, because a constant, remember, is a horizontal line. That's really what that represents. So the limit as x approaches 2 is going to be 2. And that's going to be multiplied by, and again, we have the same thing here without the exponent. The limit as x approaches 2 for x. It's an identity. So we're going to say that as x approaches 2 for x, it is going to be 2. And we're going to add that to another constant here. We have the limit as x approaches 2 is 7. So we could call this 7, and as we're approaching 2, the value 2, our output is 7, our constant is 7. So this essentially is, our limit of, and I'll write this a little bit better for you. So as our limit, as x approaches 2 for x cubed minus 2x plus 7, we will end up with 2 to the third minus 2 times 2 plus 7. And we don't need to actually write our limits now next to these, because we have found the individual pieces to solve what our limit will be. And 2 to the third is 8. So it's going to be 8 minus 4. So we have 4 plus 7 is going to give us 11. So as x approaches 2 for the function x cubed minus 2x plus 7, our value is going to be 11. Now, we didn't have any restrictions in this because it is a polynomial, and I wrote the definition here from, let's see here, what is my source for this? So for I Love Math, their definition is that a polynomial is expressions that can have constants or variables like x and or y. So we can have constants such as a 4. We can have 4x. We can have 4x squared. We could also have that being added to a 2y minus 1. That would be a polynomial. And it's for expressions that are added, subtracted, or multiplied. A polynomial can also be 3x squared over, let's say, 2, as long as the denominator is just a whole number or just a number and not a variable. If there was a variable here, that is no longer a polynomial. So just a quick refresher on polynomials. Also, exponents must be whole numbers. So if you have a term of 3x to the negative 1, well, that is no longer a polynomial. In fact, that can also be expressed as 3 over x. And again, we have a variable then in the denominator, and that is no longer a polynomial. So as long as we have a polynomial, we're not going to have any problems as far as domain restrictions. And the other key component to this is that since we are approaching 2 for a polynomial, what we can actually do is look at what our value, our limit, as x is approaching 2, we can actually insert that into the polynomial. So if we put 2, if we said that f of 2 and the function f of 2 for x cubed minus 2x plus 7, we would end up with 2 cubed minus 2 times 2 plus 7. And you'll notice that as we broke apart this polynomial, we ended up with exactly that expression. And we already know that that equals 11. So as long as you have a polynomial, you'll be able to do that. You'll be able to just, instead of breaking it apart like this as a proof, you'll be able to show that, okay, I have no domain restrictions. It definitely is a polynomial. I can go ahead and just take my value that x is approaching, plug that into the function, and I should be able to get what that limit is. So that's my first example. I hope that helps. Thanks.